Hello guys, I hope you are doing cool and welcome back today in this class, which is spanning tree protocol. What is spanning tree protocol or STP? It's a network protocol designed to prevent layer 2 loops. I hope you remember OSI layers. So spanning tree protocol is a protocol that is designed to prevent layer 2 loops, and loops, we said, loops occurs whenever there are two or more links, redundant links, okay, in a network. So STP basically uses IEEE standard of 802.1d. okay. So spanning tree protocol blocks some ports on switches with redundant links and prevent broadcast storms and ensure loop-free topology, the way we have discussed earlier. Okay. With STP, you can have redundant links between switches in order to provide redundancy. Okay. Despite some ports are put under blocking state, still there are redundant links such that when the main link is down, another link will pick up. Okay. So STP prevents loop by placing one of the switch ports in blocking state, okay, which will be enabled whenever the other link is down. Okay. So in this diagram, we want to use this diagram to explain spanning tree protocol. So in the above topology, STP has placed one port on S3, so switch 3, okay, in blocking state. So this port has been placed in blocking state, and the port will no longer process any frames except STP messages. Okay. So to prevent loops in the network, STP has put this port in blocking state on switch 3. Okay. So if switch 3 receives a broadcast frame from S1, whenever switch 3 receives a frame from S1, okay, it will not forward it out to the port connected to S2, because the port is in blocking state and can only forward STP messages. Guys, STP is a very challenging topic. Kindly understand and go for further researches. Okay. STP basically works to prevent layer 2 loops. Alright, let's see what we have next. How STP works. Basically, spanning tree protocol uses an algorithm called spanning tree algorithm, which is SPA, to create a topology database of the network. It uses this algorithm to create a topology database of the network. To prevent loops, this algorithm places some interfaces in forwarding state and others in blocking state. Okay, I hope you understand that one. To prevent loops, okay, this kind of algorithm will place some interfaces in forwarding state while others are in blocking state. So in spanning tree protocol, there are some criteria that we must understand, very important aspects that we must understand. Conditions in STP. All switches in a network elect a root switch. Let's say this is a network. We have 3 switches, okay? All these switches will go into a debate to select a root switch, okay? They will sit down and select a root switch, okay? Alright, so all working interface on the root switch are placed in forwarding state. So after these switches have elected their leader, which is a root switch, the interfaces, all interfaces in that root switch, their leader, will be put in forwarding state. Alright, criteria number 2. All other switches are now called non-root switches, and determine the best path to get to the root switch. These non-root switches will determine which is the best path to get to our leader. The port used to reach the root switch is called a root port. So the non-root switches will use a root port now to reach to the root switch. It's confusing, but kindly understand. Non-root switches will determine the best path to reach to the root switch. That best path is called a root port, and it will be placed in forwarding state. Okay, number 3. On the shared Ethernet segments, the switch with the best path to reach the root switch is placed in forwarding state. That switch is called a designated switch. Okay, and its port is known as designated port. Okay, so the switch with the best path to reach the root switch is placed in forwarding state. Alright, and that switch is called designated switch, and the designated switch ports are called designated ports. Alright, let's see in our diagram and understand better. Let's say switch 1 is our root switch, and so all ports in switch 1 are put in forwarding state. Okay, then switch 2 and switch 3 chooses port with the lowest cost to reach root switch. Okay, we said non-root switches will use root port to reach to root switch. So how to choose a root port is based on cost. The port with the lowest cost will be the root port. Okay, and these ports are placed in, the root ports are placed in forwarding state such that they can forward frames. Okay, on the shared Ethernet segment between S2 and S3, switch 2 and switch 3, port FA0/1 on switch 2 as the lowest cost to reach the root switch. Okay, this port is placed in forwarding state. Alright, and now to prevent loops, port FA0/1 on switch 3 is placed in blocking state. Okay, such that when switch 2 sends frame to switch 3 through switch 1, the frame will go like this. It will go to switch 1, and switch 1 will forward it through this interface here. Okay, and switch 3 will find it, and it will not forward it because this port is in blocking state. Alright, okay, let's see what we have next. Bridge protocol data unit. What is bridge protocol data units, or BPDUs? Okay, they are messages used by switches to share STP information with each other in order to elect root switch and detect loops. Bridge protocol data unit are basically messages that are used by switches to share spanning tree protocol information with each other in order to elect a root switch and detect loops in a network. Right? So these messages are commonly a low bridge protocol data units, which carries information like root switch ID, sender switch ID, sender's root cost, and hello and forwarding delay timers. So let's dig into spanning tree protocol. The first thing that we'll discuss is how to elect root switch in spanning tree protocol. We said in a network that comprises of switches, these switches will go into a debate to elect a root switch, while the other switches will be non-root switches. Okay, so how to elect root switch? Election is based on bridge IDs, BIDs, sent in the bridge protocol data units. Okay, election is based in bridge IDs sent in the BPDUs. Each switch that participates in the spanning tree protocol will have 8-byte switch ID that comprise of the following fields. Okay, the first field is the priority field. The priority field is always the same in all switches. Okay, by default all switches have the priority of this one. Okay, but you can change this value depending on what you want with your configuration. Then the second field is the system ID, which is always based on the MAC address of each switch. Okay, alright, so guys, after having understood what to consider while electing root switch, let's consider the below diagram. So a switch with the lowest bridge ID will become a root switch. Okay, with a number meaning better priority. Okay. So in the below diagram we have 3 switches, okay, and they are connected to each other and their MAC address has been given. So the MAC address of switch 1 is this one. It starts with 0004, then the other. This starts with 0006, then the other. Then this starts with 009, then the others. Okay, so these switches are in a debate to elect their leaders. Who will they choose? We said the choosing is based on the priority field of the switch and the MAC address. Okay, but by default we said priority is the same in all switches. So let's look at MAC address. Okay, so they are going to choose a switch with the lowest MAC address. Okay, because the statement says a switch with the lowest bridge ID will become the root switch. So these switches will check on whose MAC address is the lowest and become their leader. So let's start checking. This one is 0004, then this one 00006, then this one 0009, then this one. This one is the highest. It can't be. Okay, so we are remaining with this one and this one. 0004, 0006, 0006. It cannot be because it's higher than this one. So this one will be our root switch. Let's read the below statement. Since by default each switches have priority of this one, and now the second comparison will be based on MAC address. A switch with the lowest MAC address will carry the day as the root switch. Guys, spanning tree protocol is a little bit challenging. Kindly read and read again about these notes, okay, and try to understand. Alright, So I hope you have understood how switches go into a debate to elect their leader or root switch. Okay, let's see what we have next. Selecting STP root port. Guys, we said all unroot switches use root ports to reach to the root switch. Okay, and these root ports are in forwarding state. Let's start. Remember, all working interface on root switch are placed in forwarding state. We said that very clearly. All other switches, non-root switches, determine the best path to get to root switch, and that port used to reach the root switch is placed in forwarding state. The root port is placed in forwarding state. Okay, the best path is the one with the lowest cost to reach the root switch. Okay, this is very, very important. The best path is the one with the lowest cost, okay, to reach the root switch. So whenever there are many paths to reach the root switch, we will choose that path with the lowest cost, okay, to be our root port. Okay, the cost is calculated by adding individual port cost along the paths from the switch to the root. What we mean by that one is that whenever, let's say switch 3 wants to choose its root port. Remember, it's a non-root switch. This one is now the root switch. This is non-root switch. So a non-root switch 3, wants to choose a root port. How will it select that root port? Because there are two links to the destination, which is root switch. So it will calculate based on the cost of the paths along the way to the root switch. So the cost from S3 to S2 is 19. Then the cost from S2 to S1 is 19, meaning the total cost from S3, S2 to S1 will be this one plus this one is 38. That one is too high, 38. Okay, but S3 to directly to S1 is only 19. So it will choose this one because it has lowest cost. Okay, consider switch 3 is intending to choose a root port. Two paths are available to reach a root switch. One direct over this one, and the other you must go through switch 2. Okay, the direct path has a cost of 19 as here, while the indirect path has a cost of 38. 19 plus 19, which is higher. Okay, so that's why FA0/1 will become the root port of switch 3. Okay, because the cost of reaching root switch is lower than the other port. Okay, alright. So guys, what happens in a scenario where the cost is the same? The selection is done based on these criteria: the lowest neighbor bridge ID, the lowest neighbor port priority, and the lowest neighbor internal port number. Whenever the cost is the same. Okay, let's see what we have next. Selecting STP designated port. STP is a very challenging topic. Okay, on the shared Ethernet segments, the switch with the best path to reach the root switch is placed in forwarding state. We've been saying this all along. That switch is called designated switch. Okay, and its port is known as designated port, right? And in order to avoid loops, the designated port on the other end of the link is placed in blocking state. Okay. Then the designated switch is determined based on the following criteria. How to choose designated switch? We choose based on the following criteria. The switch with the lowest cost to reach the root becomes the designated switch. In case of a tie, the switch with the lowest bridge ID becomes the designated switch, right? So let's understand this diagram for you to understand much about designated port. Let's say switch 1 has the lowest bridge ID and has been selected as the root switch. Switch 1 is our root switch because it has the lowest bridge ID. Switch 2 and switch 3 have then determined their own root ports to reach the root switch. We said all non-root switches will select the root port to reach the root switch. Okay, so on the shared network segment between S2 and S3, a designated port needs to be selected. So on the shared network between these two switches, a designated port needs to be selected. How are we going to do this? Because switch 3 has the lowest cost to reach a root switch, the cost of switch 3 to reach switch 1, which is our root switch, is 4, while the cost of switch 2 to reach switch 1, which is the root switch, is 19. So which one will be the designated port? Okay, this one port will be designated port for the segment. Okay, because the cost is lower than this one. Then the other port on switch 2 will be placed in blocking state. Alright, so guys, spanning tree protocol is a very important topic that you can't take for granted. Kindly go for further researches so that you can understand much about it, because it's a commonly asked topic in CCNA exams. Okay, so guys, that's the end of today's class. Let's meet tomorrow. Bye and have a nice time.